terrestrial telescopes, Eta Carinae, to Hubble's eye is a spectacle of stellar violence. The star, still burning 5 million times brighter than our sun, illuminates the clouds from the inside like frosted Christmas baubles. Despite Hubble's unprecedented view, astronomers still aren't sure how Eta Carinae survived the cataclysm that for a time made it one of the brightest stars in the southern sky. Okay, so let's have a read of the article. One night in the early 1600s, Galileo got tired of using his newfangled telescope to spot ships and pointed it to the heavens instead. Suddenly, the moon had mountains. A fleet of moons encircled Jupiter, and people would never again gaze at the night sky in the same way. I expected Bob Williams to hedge when I asked him if the Hubble Space Telescope is the most significant single device to scan the skies since Galileo's discoveries. Even the director of the Space Telescope Science Institute, I figured, would hesitate at that threshold. Well, he answered, let's face it probably is. He smiled faintly, he knew he'd said a mouthful. Remember that at 2.4 meters in diameter, Hubble's mirror is dwarfed by the 10-meter twins in Hawaii's Keck 1 and 2 telescopes. While you could play football in the dish of the radio telescope at Arecibo, Puerto Rico, Hubble has no radio detectors at all, and a companion in orbit, the COPE satellite, has infrared and microwave detectors that have mapped the ancient universe. And yet it is hard to argue with the proposition. Orbiting 370 miles up above city lights and the rippling atmosphere, Hubble has confirmed the existence of black holes, revealed a rogues gallery of bizarre galaxies, ushered us to a ringside seat for a comet collision with Jupiter, and chronicled the catastrophic explosions of dying stars. Not bad for a satellite that in the beginning had something of a catastrophic reputation itself. Hubble was lifted into orbit with great pomp and expectation by the Space Shuttle Discovery in April 1990. Almost immediately, it was clear that the primary mirror was misshapen, not to any funhouse extreme, but enough to pull some sheer lace curtains across Hubble's ballyhooed windows on the universe. The telescope's true golden age began in December 1993, when the crew of the shuttle Endeavour rode to the rescue. With hinged doors and modular parts, Hubble was designed to be serviced in space. Like roadside mechanics, the astronauts pulled up to Hubble, opened the hood and installed replacement parts. They included corrective mirrors that cancelled out the existing mirror flaw. In the following months, astronomers marvelled at razor-sharp views of a universe dizzy with exploding stars and colliding galaxies, stretching off from here to the edge of eternity. When you look into space, you are looking back through time. Even at 186,000 miles a second, light requires a measurable amount of time to get from one place to another. Sunlight bounced off the moon requires a second to reach Earth, so when you look at the moon, you are actually looking at the moon a second ago. With its unobstructed view, Hubble some 11 billion years, just 2 billion years or so after the creation of the universes, to see galaxies already forming. These galaxies are speeding away from us. The farther they are, the faster they're going. The most distant approach the speed of light. In the 1920s, astronomer Edwin Hubble, above left, here he is, came up with a formula that expresses the proportional relationship of distances between clusters of galaxies and the speeds at which they're moving. But there is an unknown factor, the precise rate at which objects are rushing away from each other, the so-called Hubble constant. Among Hubble Space Telescope's chief assignments is its mission to settle on a standard Hubble constant. Bob Williams is the first to admit that in the search for the Hubble constant, Earth-based observatories are vital. Keck can gather light from a galaxy enormously better than Hubble, he said. That's essential for telling how far away the galaxy is. But without Hubble, which sees things much more clearly, Keck wouldn't know what it was looking at. So the ground's got to have Hubble, and Hubble's got to have the ground. For the rest of us, Hubble is simply the greatest tour guide ever. The Eagle Nebula's towering pillars evoke the same primal awe as Grand Teton. The violence of Eta Carina's explosion is as heart-stopping as the maw of a roiling volcano, and thanks to Hubble, we can begin to register the notion that while Earth is our local address, we have an entire universe that we call home. So, in this picture here, so it says a close look at a black hole. At the centre of the galaxy NGC 4261, a disk of dust and gas swirls into the deepest of cosmic drains, a black hole with 500 million times the mass of our Sun. Not even light can escape its intense gravity. The bright point at centre is the final flare of heated matter. So here is the telescope itself, an eye in space. In this is the high gain antennae. Here, fine guidance sensors. This is the Hubble Space Telescope imaging spectrograph, and this here is NICMOS, the near infrared camera and multi-object spectrometer. Where Hubble has looked. Oriented by internal gyroscopes powered by solar cells, Hubble's eye can sweep across virtually the entire sky. Only an area within 50 degrees of the Sun and 8 degrees of the Moon, where Hubble's delicate instruments run the risk of being damaged, is off limits. Against an illustration of the entire night sky, with the Milky Way stretching across the galactic equator, symbols indicate everywhere Hubble has looked since its launch in 1990. Some areas have been closely scrutinised, such as the two Magellanic Clouds at lower right. Another Hubble study, their serendipitous survey, randomly imaged various parts of the sky. Pictures from that study revealed a surprising abundance of irregular galaxies. So, in this illustration, we've got the North Galactic Pole at the top, South Galactic Pole at the bottom. There are the Pleiades. This is Andromeda Galaxy. Galactic Equator. Large Magellanic Cloud, Orion Nebula, a small Magellanic Cloud. So all the blue dots are Hubble's observations, and the red dots with the numbers are location and page number of images in the article here. So these three pictures at the bottom, it says inside the Crab Nebula. The star at left in the above series is a pulsar, only 12 miles wide, more massive than the Sun and spinning 30 times a second at the heart of the Crab Nebula. Images taken months apart reveal an ever-changing halo beneath the pulsar, caused when high-energy electrons are trapped in its magnetic field. Now I think this opens out. Yes, it does. Worlds without end. Hubble pointed at one of the emptiest parts of the sky, focused on a region the size of a grain of sand, held at arm's length, and found layer upon layer of galaxies as far as its eye could see. The Hubble Deep Field image required 276 exposures taken over 10 consecutive days to gather as much distant light as possible. Only a few objects in this image are individual stars which appear as spiked points of light. Everything else is a galaxy, each containing billions of stars. The large white galaxy at the top centre is one of the closest, a mere 4 billion light years away. Hubble has also seen ancient galaxies from perhaps 90% of the way back to the Big Bang. Curiously, at such vast distances, objects don't necessarily appear smaller due to distance, only dimmer. Light from the faintest, most distant galaxies in the deep field image has taken some 11 billion clearest telescopic image ever taken of the red planet. A large storm on Saturn here is seen as a white arrowhead-shaped feature near the equator in the centre. Neptune here, currently the most distant planet from the Sun, has not been seen in detail since Voyager flew by in 1989. Hubble has tracked clouds on both hemispheres of the gaseous planet. At the bottom, including high-level clouds, yellow, that reflects sunlight at the top of the image. Here. Pillars of creation. The miracle of star birth unfolds in the Eagle Nebula. Deep inside the pillars of dense, cool gas and dust, the tallest one here measures 3 light-years in height. Molecular hydrogen and dust condense into lumps that contract and ignite under their own gravity to become stars. Ultraviolet light from other stars is